Good morning, students. Today we will be going through the second part of the transformer problems. So in the second part of the transformer problems, you will be solving the problems on losses and efficiency. So before going to the problems, you need to remember one single concept, that is about the losses. So you have got two different losses. One is the iron loss, another one is the copper loss. Iron loss is a constant loss. It does not depend on any type of the loads. So this is a constant loss. Another loss is the copper loss. Copper loss depends upon the type of the load. So copper loss is a variable type of loss and it will change according to the type of load connected. Now let me go to the problem. In a 25 kVA 2000 volt 200 volt transformer, the iron and copper losses are 350 watts and 400 watts respectively. Calculate the efficiency at unity power factor at half full load. So I have already told you before, the best practice is to write the details given before. So what is the data given? You have a 25 kVA transformer. 2000 volt is the primary voltage, 200 volt is the secondary voltage. Iron loss is 350 watts, copper loss is 400 watts. So I have to calculate the efficiency at the unity power factor. UPF means unity power factor, that means cos phi is equal to 1. So you have to calculate the efficiency at half load. What is half load? So you are going to connect only half of the load to the output side. So you have to calculate the efficiency. Now what is efficiency? Now efficiency is equal to output by input. Next, what is output? Now here output is already given 25 kVA. Now again, this output will also depend upon the type of the load. Now for full load it is 25 kVA. What about for the half load? Half load means only half of the load you are going to connect. That means 25 divided by 2. What about input? Input is equal to output plus losses. Now what about the losses? Losses are equal to total losses equal to, you know already that you have got two types of losses. So you have iron loss. So let me write it as iron loss and another one you have is copper loss. So I have specified this iron loss is Wi and copper loss is Wcu. Now what is iron loss? I have already told you iron loss is constant, so it doesn't depend upon the type of the load. What about the copper loss? Copper loss is a variable loss, so it depends upon the type of the load connected. Now they have asked you to calculate the efficiency at half load. So efficiency means is equal to output by input. Now you have to calculate what is the output at half load, what is the input at half load. Now whatever they give you in the problem is always for, this is for full load. Now you have to calculate the details for half load. Now efficiency at half load will be equal to output at half load divided by input at half load. Now again, I have already told output is nothing but for half load. That means it will be equal to 25 by 2 output. 25 by 2 will give you the output in kilovolt ampere. If you want the answer in kilowatts, then what do you have to do? Now, what is kilovolt ampere? As I have already told you, kilovolt ampere is nothing but the apparent power, which is equal to the product of voltage and current. Now I want the answer in kilowatt. Why? Because my iron loss and copper loss is already in watts. That means while calculating, I can't keep one of the data in watts, another one of the data in kilovolt ampere. That is why I want to have all the data in one single unit. Therefore, I am going to calculate, or I am going to convert this kilovolt ampere to kilowatt. How can I calculate? How can I convert? Now if you see kilovolt ampere, it is nothing but V into I. So you can see there is an absence of cos phi. What about kilowatt? In the kilowatt you can see it is nothing but volt into I, current into cos phi. So if you multiply the apparent power with cos phi, you will get an answer in kilowatts. So that is what I am going to do. Now since you have to calculate output at half load means 25 by 2 into the cos factor will give you the answer in kilowatts. Now if they have asked you, for example, 1/4 of the load, that means 25 by 4. So that is the only difference. Since they have asked half load, 25 by 2. If they have asked 1/4 of the load, 25 by 4. Clear? Next. I have already told iron loss is constant, copper loss is variable. Iron loss is constant, that means 350 watt, it will remain the same. Copper loss changes. Now how can you calculate copper loss for different type of the load? So you have a formula here. So x square into full load loss. What is x? X will give you the type of the load. So what is the type of the load here? Half. So x is equal to half. Half whole square into the full load copper loss. What is the full load copper loss? So full load copper loss is given as 400 watt. So let me calm down. So half square into 400 will give you the copper loss at half full load. So what is the total loss? Total loss is nothing but iron loss. Iron loss. So plus the copper loss. So let me calculate what is total loss. So this is the copper loss plus iron loss will give you the total loss. Now I'll keep it in kilowatts itself. Why? Because if you see here, output you have in kilowatts. If you keep the total loss also in kilowatts, then it will be easier to calculate. Why? Because you already know efficiency means output by input. What is input? Input is nothing but output plus losses. Now output is in kilowatt, losses also in kilowatt, so you will get the input in kilowatt. So output is in kilowatt, input is in kilowatt. Kilowatt cancels, it will be easier. So next, calculate what is input. Input is equal to output plus losses. So output at a half load, losses at half load. So calculate that, then you can substitute in the efficiency. You will get the answer for efficiency at half load. This is what you have to do. I hope it is clear. Now let me go to the second problem. A 50 kVA transformer has an efficiency of 98% if full load, 0.8 power factor, efficiency of 96.9% at 1/4 of the load, unity power factor. Determine iron loss and the full load copper loss. So what is the given data? They have given you the efficiency at full load, so 98% at full load. So this is what power factor is 0.8. Efficiency of 96.9% at 1 by 4th of the load, so 96.9 at 1 by 4th of the load. Cos phi is equal to 1. So you have to calculate the iron loss and copper loss at full load. So IL plus FLCL. So since they have given you the data for two parts, full load and 1 by 4th of the load, let me divide this problem into two parts. Now what do you have to calculate? Iron loss plus full load copper loss. Okay, now what you already know, efficiency is equal to output by input. Now what is input? So if I write this, so I have output divided by input means what? You have output plus losses. Now what is losses? Iron loss plus copper loss, that is FLCL. This is the notation that I am using here. So efficiency is given 98% equal to output. You can calculate. Why? Because 50 kVA is given, so you can calculate the output for different type of the load. Next, divided by output, again the same, plus iron loss, you can use it as IL plus FLCL. Now you have got two datas here, full load, copper load, correct? That means I can use this equation for two types of the loads. What happens? I will have an equation, one equation for full load, one equation for half load, 1/4 load. I have two equations. I can use those two equations to find iron loss and the full load copper loss. You will understand this better further. Let me see. So what do you have to calculate? As I've told you before here, you have to calculate output. You have to calculate output for different type of the load. Output at full load, now I have already told you this is for full load. Same, this one you can use 50 kVA. So 50 kVA, you have to convert it into kilowatts, so directly multiply with the cost factor. Next, what is input? So I have already told you input is nothing but output plus losses. What is output? 40 kilowatt plus losses again. What is losses? Iron loss, and another one is full load copper loss. So 40 plus IL plus FLCL. Now again I told you I want everything in the same unit. So again iron loss and copper loss also in the kilowatts. So I have written it like this. So what happens is my kilowatt will cancel when I am going to substitute in the efficiency formula, and it becomes easier for me to calculate. So if you substitute that, you will get this equations. So what are you going to do next is you are going to cross multiply. So when you cross multiply like this, you will further end up with this equation. So equation 1, this is what I was speaking before. Now same procedure I am going to follow for the next type of the load, that is for 1/4 load. Again I will get a second equation. So use the two equations to find out the variables. So quarter load. So again I have to calculate the output at quarter load. So output at quarter load will be 50 kVA divided by 4 into the cost factor. Next, iron loss is constant, that is what I have written here. Copper loss changes. So copper loss you have to calculate for quarter load. So how can you calculate the loss at different type of loads? it is equal to x square into full load copper loss. What is x? X is nothing but the type of the load. What is the type of the load? That is nothing but 1/4 load. So 1/4 whole square into full load copper loss. So again substitute it in the equation. So input is equal to output plus losses. So output plus losses. Efficiency formula then output by input. So substitute in that as previous, similar to the previous one. You will get a second equation like this. Next, use two equations, these two equations. So equate this. So you can substitute, you can solve this using your calculators. So use the equation mode. So if you put it in the equation mode, use these two equations, you will get the answer for two variables. So that is how we are going to solve the problem. Next, problem 3. A 600 kVA single phase transformer has an efficiency of 92% both at full load and half load at unity power factor. Determine its efficiency at 75% of the full load at 0.9 power factor lag. So what data is given? 600 kVA. Next, efficiency of 92% at full load and half load. So for full load and half load both 92% efficiency. Power factor is again 1. You have to find out what is the efficiency at 75% of the load at 0.9 power factor. Now how can you find out that? Now again, efficiency is equal to output by input. Now, so output divided by input. What is input? Input is nothing but output plus losses. What is losses? Iron loss plus copper loss. Now again, iron loss is constant, copper loss will change for the type of the load. So output at 75% of the load. So this I have to calculate for 75%. So here again iron loss is constant, so no problem. This I have to calculate for 75% and efficiency for 75%. So how can I proceed? First, efficiency at 75% you are going to find out, correct? Next, output at 75%. Can you calculate that? 600 kVA is given, so that means output at 75% easily you can find out. Next, what about the iron loss and copper loss? What do you know about it? Now if you see here, iron loss and copper loss is not given. Now if you don't know the iron loss and copper loss here, how can you find out the efficiency at 75%? So what do you have to do? Before going into this efficiency of finding out this efficiency of 75%, you have to first find out this. How can you find out? The same procedure that we had followed in the second problem, that we are going to follow in this problem also. So what I am going to do, again I am going to divide the problem into two sectors. First is for full load, another one is for half load. The third part would be for the 75% of the load. So full load, I am going to find out the output for full load, that is converting into kilowatt. Next, efficiency equal to output by input. Okay, now I need to find out what is the input. So what is input? Efficiency is given, output is given, I can find out the input. So input is equal to this much. Now what is input? Input is equal to output plus losses. Now what is my aim? My aim is to find out this variable in input loss plus copper loss, iron loss plus copper loss. How can you find out the iron loss plus copper loss? That is by using this equation. That is, if you see here, output you know, input you know, can you find out the losses? Correct? So total losses is equal to input minus output. So what is input? Here, given here. What is output? Calculated here. So you can find out the loss. So what happens? This is nothing but equal to iron loss plus full load copper loss. So iron load plus full load copper loss is equal to 52.2 kilowatt. Let me follow the same procedure for the half load now. Output at half load. So 600 kVA divided by 2 into cos phi will give you the output at half load. Next, let me go down. Efficiency. Output is calculated. Efficiency is given. You can calculate the input. Once you get the input, go to this equation. What is input? Input is nothing but output plus losses. Now what is losses then? Input minus output. So input you have calculated here, output you have calculated previously here. Correct? So that means you can calculate the loss. Now what is losses equal to? Losses is nothing but iron loss plus copper loss. Correct? Now again, iron loss is constant, so no problem. What about the copper loss? Copper loss changes. That means what will be your equation? X square into full load copper loss. X is nothing but half load, so half square into full load copper loss. That means full load copper loss at half load will be equal to full load copper loss divided by 4. Right? So what will be your equation? 26.1 kilowatt. What is this 26.1 kilowatt? This is nothing but the losses that you have calculated here for half load plus equal to iron loss plus copper loss at half load is nothing but full load copper loss divided by 4. So if you use this equation 2 from half load and if you use the equation 1 from full load, substitute that both in your calculators, you will get the answer for these two variables. Now what was your question? You had to find out the efficiency at 75% of the load, right? So for the 75% of the load, you have to calculate now what is your copper loss. So once you calculate the copper loss here using this equation, so what is X now? X is nothing but the type of the load. What is the type of the load? That is, type of the load is 75% of the load. So 75% means I have to substitute as 0.75 into the full load copper loss. That will give you the copper loss at 75% of the load. Now total loss, that is, this is your iron loss which doesn't change, and this is the copper loss that changes. So if you add this, you will get the total loss. Now another thing that you have to calculate is output at 75% of the load. Now this is your 600 kVA that is given into the cost factor will give you in kilowatts into the type of the load. What is the type of the load? 0.75, that is 75%, so into 0.75. So that will give you the output. So you can substitute that in the efficiency equation. So output that you have calculated, input is nothing but output plus losses, so output 405k plus the losses that you calculated here. So substitute that, you will get the efficiency for 75%. So these are the type of problems that you have in the second part. So what are the different things that you need to remember here is, one is iron loss is a constant loss, so doesn't depend upon any type of the loads, it will be constant for everything. Copper loss changes. Copper loss is a variable loss, it will depend upon the type of the load, therefore you will, for different type of the load you will have to calculate the copper loss. So how can you calculate? So I have already given you one equation. So x square into the full load copper loss. This is how you calculate copper loss. Next, the next important thing that you need to remember here is your output also changes depending upon the load, correct? So if it is half load, then you need to calculate that. If it is 1/4 load, then divided by 4 here. So it is 75% of the load, that means into 0.75. So this you need to calculate. Another thing that you need to remember is this formula, efficiency formula. So 4 things to remember. Practice the problems, you will be clear with everything. Thank you.